4.4 trig form of a complex number. Let's start with reviewing the complex plane. When we introduced the complex numbers, we said we have the real numbers right here on the x-axis, if you think, and the pure imaginary numbers on the vertical axis. And so 1, 2, 3 on the real axis, and the negative I is right here, 2i, and so on. So if we want to plot the numbers 3 plus I, would be right here, 3 plus I. So a complex number has standard form a plus bi, where a is the real part and b is the imaginary part. So that's how we introduce the complex numbers first. Now, we're going to talk about trig form of a complex number versus the standard form, which we're already familiar with, standard form, but now a trig form. Let's give a definition first. Definition of absolute value of a complex number. Absolute value of a complex number, z, in a standard form, a plus bi, is the following expression, square root of a squared plus b squared. In other words, this is the distance between the origin and the number. That express, it's always positive, the distance between the origin, 0, 0, and the number. So let's see that on the picture. Here's our number, 3 plus I. So this distance here, it's the absolute value of z. Okay, example. You don't have to graph the number to find the absolute value. You can just calculate it. Square root of the real part squared plus imaginary part squared. So if our number z is -2 plus 5i, we're going to do two things. A, we're going to plot it. And B, we're going to find the absolute value of z. So let's plot it first. We need -2 for the real part. You can pick whatever scale you like. And then 5 on the imaginary part. So the number is right here in the second quadrant. So that's our number z, -2 plus 5i. So now we have to find the absolute value of z. The absolute value of z will be square root of a squared plus b squared. This is our definition, which is square root of -2 squared. You always have to put negative numbers in parentheses, plus 5 squared. So it's square root of 29. We can just leave it like this if we cannot simplify it. So that's our review on the complex plane. Number 2, we're going to talk about a new form called trig form of a complex number. We'll start with drawing a picture. This time a complex number is in the first quadrant. It doesn't have to be, it could be anywhere on the plane, but if it's in the second quadrant and the coordinates of that endpoint, that point here, it's AB, then the distance from the number to the origin, the absolute value, we'll call it R. So R is the same as the absolute value of z, and it's already have a formula, square root of a squared plus b squared. Now, a is the real part here, and b is the imaginary part. If we use trigonometry, and if we name this angle theta, then we can say a is r cosine theta, and b is r sine theta. From the right triangle, we do SOHCAHTOA to express that. So you can use that reference angle in this right triangle here to do SOHCAHTOA and write those two expressions. So now our number z, that was a plus bi, we can substitute a with r cosine theta and b with r sine theta, and we can also factor r. And in this way, we will obtain a new form called trig form. So this is the trig form of a complex number. Let's write this as a formal definition. Trig form. Sometimes it's called polar form. Polar coordinates, polar form. So z equals a plus bi, that's the standard form, is also z equals r cosine theta plus I sine theta. So remember what r was. R is the absolute value, so we can divide it. And the angle, how do we find the angle? Well, if we take a tangent of the angle, which is opposite over adjacent, so that's b over a. So the r, we call it modulus of z, and theta, we call it argument. The angle, we call it argument of z. So that's how we go from standard form to trig form. These are the two formulas we need to go from standard to trig form. Trig form is not unique since the angle, since there are infinitely many coterminal angles. So let's write this down as a note. Trig form is not unique. What that means is, instead of angle theta, I can do theta plus 2 pi or theta minus 2 pi, so we have infinitely many angles. So we need to restrict the angle theta to be from 0 to 2 pi. Then we have a unique trig form. Example, write z equals negative 2 minus 2 root 3I in trig form. So first we need r, or the absolute value, which is negative 2 squared plus negative 2 squared. Very important to put negative numbers in parentheses. So that will be here. I missed something. I did not square the root 3. Here you go. That's better. So that is 4 plus 12. So square root of 16, which is 4. So the modulus, or the absolute value, doesn't have to be always integer. Could be rational. So that is 4. Let's sketch and see where that number is. So negative 2 right here, and negative 2 root 3 probably here. Our number is in the third quadrant, connected. So this is our number, z equals negative 2 minus 2 root 3I. The angle theta is this one. So to find this angle, I'm going to use a reference angle. Here, theta prime is reference angle. Theta prime is reference angle. If you remember, reference angle is the angle between the terminal side and the x-axis. So in that angle, I can take tangent of theta prime, which is opposite. So what's the opposite here? Right here, that is 2 root 3. And the adjacent is 2. We're talking about the length. Tangent is going to be positive here because we are in the third quadrant where sine and cosines are negative. So tangent is positive. 2 root 3 over 2. I'm using SOHCAHTOA, cancel. And this is root 3. So I can actually find that angle because it's in my table. I know tangent of what angle is root 3, and that's 60, or pi over 3. So my angle theta prime, pi over 3 is the reference angle. My angle theta is pi plus pi over 3, which is 4 pi over 3. So I know the angle, I know the absolute value. Let's write this down. So R, or absolute value of Z, is 4, and the angle theta is 4 pi over 3. So I can write the trig form now. Z is equal to, let's write the formula first, R cosine theta plus I sine theta, which is 4 cosine 4 pi over 3 plus I sine 4 pi over 3. And I'm going to stop here because if I keep simplifying, I'll go back to the standard form. So we stop here. This is the trig form. Example B, so that was A right here. Example B, the number in standard form is 6 plus 2i. Same thing, write the trig form. Write in trig form. We could sketch it. It's in the first quadrant, so 6 is here, 2 is here, and here's our number Z right here. Let's find the absolute value, or the modulus, square root of 6 squared plus 2 squared. So it's square root of 40, which we can simplify to 2 root 10. And for the angle, tangent theta, I don't need reference angle because I'm in the first quadrant. So tangent of theta would be the opposite 2 over the adjacent 6, which is 1/3. And I'm not familiar with this angle whose tangent is 1/3. In other words, it's not in the table we memorize. So we're going to use a calculator to find the angle. I'm going to do arctangent or inverse tangent of 1/3. And we can do radians or degrees. I'm going to do degrees, 18.4 degrees, or we can leave it as arctan 1/3. So number Z in a trig form will be R cosine theta plus I sine theta. Always write the formula first. R was 2 root 10. And here cosine of arctan 1/3, or you can use the abbreviation, plus I sine arctan 1/3, or you can use the degrees, cosine of 18.4 degrees plus I sine 18.4 degrees. And we stop here because if we keep going and use a calculator to simplify this, we'll get back to the standard form. Another example, write the complex number in standard form. Write the complex number in standard form. So that's the opposite. They give you the trig form, and I want you to write the standard form, which is easier. So here's what's given. Z is equal to square root of 8 cosine of negative pi over 3 plus I sine negative pi over 3. So we know that number is in the fourth quadrant. We don't have to sketch it. Well, we could. It's somewhere in the fourth because I know the negative pi over 3, somewhere here. And this is our angle. But what we need to do is calculate cosine of negative pi over 3. Cosine is positive here, 1/2, minus, because here sine is going to be negative, so it will be minus I root 3 over 2. We know those values from the table. And after you distribute here, we're going to have square root of 8 over 2 minus I square root of 24 over 2. And after we simplify it, because square root of 8 is 2 root 2 over 2, and square root of 24 is 4 times 6. So I times 2 times square root of 6 over 2. So we cancel the 2's. And what's left is root 2 minus root 6i. So this is the standard form. Number 3, in the lesson, we'll talk about multiplication and division. Multiplication and division of complex numbers. We already know how to do that in standard form, but we're going to do this in trig form, which would be a lot easier. So no more foiling, multiplying by the conjugate of the denominator will be a lot faster. If I have two numbers, z1 in a trig form, r1 cosine theta 1 plus I sine theta 1, and another number, z2 in a trig form, r2 cosine theta 2 plus I sine theta 2. And if I want to multiply them, there is a formula. So you multiply, we're actually going to derive that formula here. We multiply R1 and R2, obviously, and then we have cosine theta 1 plus I sine theta 1 times cosine theta 2 plus I sine theta 2. All right, so if we FOIL and combine like terms, we're going to have R1, R2 here, but after we FOIL, we're going to have cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2. Notice that we have I times I here, which is I squared, which is negative 1. And then plus I, I'm going to combine the terms with I together, sine theta 1, cosine theta 2 plus sine theta 2 cosine theta 1. And if you recall, these are formulas we did earlier. So the first part right here, this part is actually cosine of the sum, theta 1 plus theta 2. And then this part that's factored with the I is actually sine of theta 1 plus theta 2. And this is our formula. So let's write this formula as a definition. When we multiply two numbers in a trig form, so let's write this down. Our first number is z1 r1 cosine theta 1 plus I sine theta 1, and the second number is z2 r2 cosine theta 2 plus I sine theta 2. If we want to multiply them in a trig form, so the product z1 times z2 is r1 r2, so we multiply the modulus or the absolute values, and then we do cosine of the sum plus I sine of the sum. Okay, so we add, let's just emphasize this, and when we have a product, we multiply these two, but we add the angles. Now, we don't have time to prove it, but the quotient formula is very similar. If we divide two complex numbers in trig form, we are dividing the modulus, but then we subtract the angles. So the order is very important. So let's highlight here that the quotient, when you divide the r's, but you subtract the angles. So that's very important. Now also I need to add here for the division that z2, the denominator, should not equal to 0. So example, if I have two numbers in the trig form, z1 equals 24 cosine of 300 plus I sine 300. So now the number is in the fourth quadrant, but we're not going to sketch them. z2, another number is 8 cosine 75, everything in degrees, plus I sine 75. You have to have everything in degrees and everything in radians, so it has to be consistent. So find z1 divided by z2, the quotient. So z1 divided by z2, according to the formula, would be dividing the r's and then subtracting the angles, degrees. Okay, so let's simplify this. So we can do this 3, and here cosine of 225 degrees plus I sine 225 degrees. And depending on instructions, if they ask you to leave it in the trig form, then we'll stop here. But if they ask you to write it in the standard form, you need to continue, because we can simplify cosine of 225 is negative root 2 over 2, plus I sine of 225 is negative root 2 over 2. You can use reference angles, draw a picture, and then multiply finally negative 3 root 2 over 2 minus 3 root 2 over 2I. So this is the quotient of those two given numbers in a standard form. Last example. I have two numbers in the trig form. Z1 is 2 cosine 2 pi over 3 plus I sine 2 pi over 3. This is in radians. And Z2 is 8 cosine 11 pi over 6 plus I sine 11 pi over 6. And we want to multiply them. So Z1 times Z2, we multiply the modulus, 2 times 8. And if you recall the formula, what we do with the angles, we add the angles. Okay, plus I sine, we add 2 pi over 3 plus 11 pi over 6 equals 16. Now, let's add those two, this common denominator 6, 15 pi over 6, seems like, plus I sine 15 pi over 6. I can simplify this by dividing by 3. So that's actually cosine of 5 pi over 2, good angle, plus I sine 5 pi over 2. And again, if they ask you to leave it in trig form, you stop here. But we can keep going to the standard form, because cosine of 5 pi over 2 is the same as cosine pi over 2. Find a coterminal angle by subtracting 2 pi, and 5 pi over 2 is actually 2 pi plus pi over 2, which is pi over 2. So it's easier if you pick the smallest coterminal angle, and now cosine of pi over 2 is 0, and sine of pi over 2 is 1, so we end up with 16i. And this concludes the lecture.